Naming ionic compounds. So there's different types of ionic compounds, and how you name them is influenced by what the metal is inside of them. So the first type that we're going to discuss is if the cation is from group 1A, 2A, 3A, or zinc. So 1A, 2A, 3A, zinc, silver. So Zac in group 1A, 2A, and 3A. For these ones, you don't need Roman numerals. You can just write out the name as you see it without having to figure out the Roman numeral for it. So these are the only ones you don't need to include a Roman numeral as part of the name. So when we're naming these formulas here, you'll see that I do not try to figure out the Roman numeral. All I'm going to do is just name the element and move on. That's it. It's really simple. These are the easiest ones to do because you don't have to sit there and do anything cute with it. So for the first one, CDO, well, we know that's cadmium. Do I need to point out what the charge is? No, we don't care. And O is oxide. Remember, the second element ends in IDE unless it's a polyatomic ion. So the way this works, keep the first syllable and drop the rest and put ID in its place. So oxygen becomes oxide. Notice I kept the first syllable and put ID in its ending. That's the way it basically goes. So for these ones, once again, all you have to do is just name the metal, and that's it. And the nominal, of course, whatever it's attached to. For this one, potassium dichromate. It's a polyatomic ion, I could tell because I memorized it, but also because there's three capital letters, right? It's a clear-cut sign that there's a polyatomic ion involved when you see three different capital letters. And I do in this situation, so I know it's a polyatomic ion. I just name the metal, name what it's attached to, and that's it. Nothing else. There's no one crisscrossing, nothing cute going on. These are the best ones to do. Zinc, also one of the members of this unique group, just becomes zinc iodide, sodium chloride, zinc again, polyatomic ion because you see three capital letters, so that's going to be sulfate, cadmium, carbonate, polyatomic ion again, three capital letters. So all you're doing for these ones, once again, just naming the metal, naming whatever it's attached to, and that's it, nothing else. Now, the other kind was what happens if they're not 1A, 2A, 3A, or ZAC? What do you do then? In those situations, you actually have to do some detective work because you need to figure out what the Roman numeral is because that's necessary for the formula. So where these words were really easy, this requires a little bit more thinking. So you're going to start by crisscrossing. So how do you crisscross? Well, the 3 goes back up here. Remember, it belonged to the iron. That's how you crisscross. And since there's no number here, you assume chloride's a -1. Now, because the chloride has the correct charge, we know this is the correct charges. And you understand what that means in a minute when I go over some examples where that's not true. So for this one, it's just going to be iron. And yes, you need a Roman numeral. That's why you did the whole crisscross thing. 1, 2, 3. Why 3? Positive 3 charge. And then chloride. So you see that the anion is not influenced by any of this stuff. You still do the same we did up here. But the cation, you need a Roman numeral now. Lead is not 1A, 2A, 3A, or ZAC. So uncrisscross, Pb2 plus, uncrisscross, SO4, 2 minus. This is where the challenge comes in. Oh, sorry, it's actually a -1, not a -2. This is where the challenge comes in because if you look at this, the 1 came from down here, right? But we know sulfate's not a -1 charge. What is sulfate really? It's a -2. So what happened? How did it become a -1 out of nowhere? Because that's not possible, right? They reduced it. Remember how when you crisscross, you reduce the numbers at the end? Well, it turns out you can go the other way as well. And this situation, what happened is that they reduced the numbers. So how do I unreduce it? Well, you look at the polyatomic ion, whether the anion is, doesn't matter if it's a polyatomic ion or not, and you're going to multiply by whatever value gives it the correct charge. We know that sulfate should be a -2, so I'm going to multiply by 2. Since I'm doing it to this, I also have to do it to the cation, so I'm going to multiply that by 2. So we end up getting lead, +4, SO4, -2. So the anion has the correct charge. Remember in this situation, it had the correct charge from the get-go, so we don't have to do anything like this. This one it didn't, so you have to take that extra step. So ordinarily, at first sight, you would say, oh, this is lead 2 sulfate. That's the wrong answer. The correct answer is lead 4 sulfate. And that's because the fact there's a Roman numeral 4, because the charge is 4, right? So the thing you have to do when you crisscross these ones for the ones not in 1A, 2A, 3A, or ZAC, you have to look at the anion. If the charge is correct, you're done. Just name what you see and move on with your life. If it's not, you do have to go this extra step of figure out the correct charges. So next one, gold, you uncrisscross, you get OAU, positive 3, crisscross nitrate, negative 1. These are correct charges. So gold, 3, nitrate. And you're done. This one, uncrisscross, so AG, there's no number here, so it's a 1. P becomes negative 3. P does have the correct charge, so we're good. So it's just going to be silver. No Roman numeral for this one because the fact is a member of ZAC. And what you'll notice with this one, I could have actually just skipped this whole crisscrossing altogether, right? And the reason for that is because it is a member of ZAC. I do not need to uncrisscross. What I could have done from the get-go, just said silver phosphide. So be aware that the shortcut with the 1, 2A, 2A, 3A, and ZAC does save time, but you could also do what I just did, go to the process and still come up with the same answer. You just have to remember that silver is not a Roman numeral 1. All right, what if there are no subscripts? Well, if there's no subscripts, then the charge is going to be the same as the anion. So what does that exactly mean? All right, for this one, you notice there's no subscripts for this, right? So when I crisscross it, I would have ended up with this. Sorry, 1, 0, negative 1. We know carbonate's on negative 1, so we have to sit there and multiply it by 2, multiply it by 2, and we get the correct charges, positive 2, negative 2. Now we're good. Now we could have called it strontium carbonate. What I'm trying to tell you here is that you could have shortcutted this by just looking at the strontium and the carbonate and said, you know what? Because there's no subscripts whatsoever. And for those like, well, what about the 3? The 3 is part of the polyatomic ion. It's not counted. If I had parentheses and a 2 or 3 on the outside, then yeah, you look at the subscripts there too. But in this situation, 1-to-1 ratio. So whatever the charge of this is the charge of the strontium. Now, I didn't even have to go through all this because strontium is a group 2A element. So technically, what I could have just said is, okay, strontium carbonate, have a nice day. But I wanted to show you the logic or process of this. So when you see no subscripts, if it is a metal not from group 1A, 2A, or 3A, which you could really do really quickly, is just forget the charge in the anion, say that's a charge in the cation, and move on. So I'll show you an example, but in this situation, SNO, we know that when we crisscross this, this would have been positive 1, negative 1. We know it's not correct. So let's look at the O. 1-to-1 ratio, right? So we know O for a fact is negative 2. So guess what SN has to be? Positive 2, right? Because the charge has to be 0. So your formula for this becomes 10 to oxide. So I basically avoided the whole crisscrossing and then sitting there and figuring out what number to multiply by just noticing it's a 1-to-1 ratio. So the charge in the metal has to match the charge of the non-metal. It's a shortcut for it. Same thing here. No subscripts, right? So 4 is part of the formula. The 4 is part of the formula. So this is a negative 2. So guess what lead has to be? Positive 2. So lead, Roman numeral 2 to represent the positive 2, sulfate. You're done. Here, once again, no subscripts. So this is going to be a negative 2 for chromate. Tin has to be a positive 2. So tin, 2. This is why it's so important to memorize those polyatomic ions, because otherwise this would be an impossible question to do. But by knowing them, you speed up the process drastically and you're able to get the correct answer. If the charge of the anion does not match the periodic table, then multiply both by the cation. what I just did, right? Multiply both by whatever number makes the anion have the correct charge. So whereas this was kind of a shortcut, here is where you don't have shortcuts. So let's go through the process. So cobalt is not group 1A, 2A, 3A, or ZAC. So I'm going to crisscross CO, positive 3 charge, P, this is a 1 here, negative 1. We know that's not correct because P should always be a negative 3 charge, right? Because it's a group of 5A. So I'm going to multiply both of these by 3. So I get CO 6 plus, P negative 3. This becomes cobalt 6 phosphide. So these are the hardest questions, really, is when you have to sit there and do this little extra stuff. But there's no way around it. Okay, here I'm crisscross again. PB positive 2, S negative 1. We know it's not correct. S should be negative 2, so we're going to multiply both by 2. We get lead positive 4, S negative 2. This becomes lead 4 sulfide. Okay, next one. This is where it sucks when there's subscripts because you have to go through all this extra stuff, especially if it's not 1A, 2A, 3A, or ZAC, right? So 10, another example on crisscross, SN, 2 plus, O, negative 1. We know O should be a negative 2, so we're going to multiply both of these by 2. So this becomes SN 4 plus, O, negative 2. So now we have tin 4 oxide. Here, once again, on crisscross, CO, positive 2, PO4, negative 1. We know PO4 should be a negative 3, so we're going to multiply both of these by 3. CO, positive 6, PO4, negative 3, so cobalt 6 phosphate. Next one, crisscross SR, positive 3, S, negative 1, right? Just crisscross. So we know S should be negative 2, so we're going to multiply it by 2 and the other one by 2. We get CR, positive 6, S, negative 2. So we get chromium 6 sulfide. VO2 on crisscross, V, positive 2, O, negative 1. Multiply both of them by 2 because O should be a negative 2, right? So V, positive 4, O, negative 2. So vanadium 4 oxide. So you can see the really difficult ones is when you don't have group 1A, 2A, 3A, or ZAC, because in those situations, with at least zinc, ZAC, just a reminder, at least with these ones that set charges, you have to sit there and try to figure out the charge and do this whole crisscrossing thing, and your life becomes easier. But whenever it's not 1A, 2A, 3A, or ZAC, you have to actually crisscross. Unless, of course, you get some cool ones like the ones we just did a second ago, where there is no subscripts and you could do the ultimate shortcut. But those are pretty much your only options to get these formulas correct. And that's how you do formula writing.